All right, so again, we're still looking in 5-4. We did 1, 2, 3, and 4, but we're on the very last problem, number 5. And this is actually a great one to start kind of coming back from break because it reviews a lot of things from 5-3 and 5-4 all together in one big problem. So again, I'm on number 5. It's the last page of your 5.4 notes before we get into 5-5. And you might see this big statement and think like, what is this nonsense that Miss White's about to make us do? It's going to be okay because we're going to break it apart. We're going to look at this first part by itself first. So it says sine, and this symbol is alpha. You can use an A if you don't like the little Greek symbol for alpha. It doesn't matter to me. Sine of alpha is 3/5. And then it says pi over 2 is less than alpha, which is less than pi. That helps me know where on my like unit circle-ish area this angle is. So let's draw a coordinate plane. I've got my y-axis, I've got my x-axis. I'm not saying you lost all brain cells from spring break, but let's pretend like you lost some and don't remember some of this. I'm going to go back to the basics. Remember unit circle, we go 0. It tells me in terms of pi, so I'm going to use pi's, not 90, 180. So this one's pi over 2. I've got pi over here. I've got 3 pi over 2, and then I'm back to 2 pi. All right. It tells me that we're doing this angle is between pi over 2 and pi. So that means it's somewhere in the second quadrant. It truly doesn't matter where in the second quadrant it is. It just matters that it's in the second quadrant. So I'm going to draw like an angle in here. Again, it can be as high or as low as you want. I'm going to finish it off to make a little right triangle. The angle we're always looking at is closest to the origin. So I'm going to write a little alpha close to the origin. And then again, not to be rude or assume you don't know anything, but just to remind us of kind of basic things, basic tools in our toolbox. We remember SOHCAHTOA. SOHCAHTOA. If sine was given to me, sine is so that means it's opposite over hypotenuse. So in my little pink triangle I drew in that second quadrant, I'm going to label my opposite side 3 and my hypotenuse 5. What I want to do next, though, before I figure out any other thing that's given to me in the direction, let's like finish this triangle. Let's actually solve for this last side. If we can find the adjacent side, then we could find any trig functions ever given to us. You might recognize this as a special triangle, but even if you don't, we can do Pythagorean theorem. 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. X squared equals 16, so x equals 4. We've done enough of these that like I remember that 3, 4, 5 is a special type of triangle. The only thing I don't want you to forget is since it's in the second quadrant, this is going to be not a positive 4, but a negative 4. Because we went to the left instead of the right. Okay, now whatever they ask me about alpha, I can find. I can find sine, I can find cosine, I can find tangent. I could even find cosecant, secant, cotangent if I wanted to. All of those things from just one angle. And we found that by knowing what sine was and then what quadrant we were in. Any questions so far? Okay, now we're going to do this with the other triangle, or the other angle, excuse me, because this now says cosine of b, which is beta, equals 5/13, and it says 3 pi over 2 is less than b, which is less than 2 pi. So that means now I'm in the 3 pi over 2 and 2 pi quadrant, which is quadrant 4. So I'm going to draw a triangle somewhere in here. And my cosine, or my adjacent over hypotenuse, is 5/13. So again, I now know what angle I'm in, and you can have as high or as low of a triangle. It doesn't matter what your triangles look like. Got a nice little triangle here. I'm going to call it beta, like a little fancy B in there. And then cosine adjacent over hypotenuse is 5/13. So I'm going to write 5 and 13. Just like the last one, I need to solve the triangle. So this time I'm finding my vertical distance, not my horizontal distance. Anybody questions so far? Okay, let's do a little Pythagorean theorem. This is another special triangle. I just know because we've done a few of these. But if you didn't, we just Pythagorean theorem, 25 plus x squared equals 169, minus 25 from both sides, x squared equals 144, and so x equals 12. And now since this is in the fourth quadrant, I'm going down for my opposite. It's going to not be positive 12, it's going to be negative 12. So all we did was just take a sentence, like a line of text, and make it a picture, which has way more information now. We know what quadrant things are in. We know their opposite, adjacent, and hypotenuse sides. We know these two different shapes. Now we essentially have two triangles. Okay. Any questions so far? Okay. Now, all of these say find, and they're basically our equations or our formulas that we learned back in 5.3 and 5.4. So sine of alpha plus beta, that's a sum and difference formula. Tangent of alpha minus beta, another sum and difference formula. Cosine of 2 alpha, that's a double angle. Cosine of beta divided by 2, that's a half angle. So all four of these have special like formulas that we're just going to scroll up in our notes and find. If you have nice, pretty organized notes, you might be able to just like cut and paste. Mine are not that nice. So let's go find sine of alpha plus beta. So we're adding and subtracting two angles. I know that that's in 5.3. Sum and difference identities are in 5.3. So I'm going back to like kind of the front of my notes here, and we want the sine one. So I'm looking at this first one. I'm going to highlight all of that. Oh, it's even written in terms of A and B. So you can think of that as alpha and beta. So I'm going to physically either copy and paste, or I'm going to rewrite this down on my next problem. Sine of A, cosine of B, plus or minus sine of B, cosine of A. It does say signs match. So whatever sign is in the problem is going to be the sign that's in the middle. So, okay. Sine A, cosine B, sine B, cosine A. Okay, let me go write that down. And you can keep it as A and B, or you can write it as alpha, beta. I'm going to say sine of alpha, cosine of beta. Again, your signs must match, so it's going to be plus. And so I'm going to say sine beta cos alpha. All right, you might be like, all right, this is all fun and games, Miss White, but now what? Well, now what? We just use what we found a minute ago. We have this beautiful picture up here. We can easily find sine of alpha, cosine of alpha, sine of beta, cosine of beta. So the first one, sine of alpha, is opposite over hypotenuse. So I'm going to write 3 over 5 for my sine of alpha. Cosine of beta, I got to look at my beta. Cosine is adjacent over hypotenuse, so 5 over 13. I'm going to keep consistent with my colors. Then it's plus, because again, the signs have to match. And now I have to do sine of beta. So back to the orange triangle. Sine is opposite over hypotenuse, so negative 12 over 13. And then cosine of alpha is adjacent over hypotenuse, which is negative 4 over 5. Everyone cool so far? All right, now we're just going to multiply our fractions, add them together. I was tempted when I did this by myself to cross out these fives. I'm going to argue that I don't want to do that now because I want like denominators in the end to add the two fractions up. And 5 times 13 is going to be the same denominator as 5 times 13. So we're just going to keep it unsimplified. If we need to simplify later, we'll do that. So remember, when we're multiplying fractions, you have to do the tops together and then the bottoms together. That was an unhelpful highlight. 15 over 65, I think. Yeah. And then negative 12 times negative 4 is a positive 48 over 65. And again, I didn't simplify because now I'm easily able to add 15 and 48, and that becomes 63 over 65. And that's my answer. That's it. Since I have all these nice, pretty fractions up here, it was able to simplify down easily to one number. Anybody questions so far? All right, the next one's very similar. So I'm gonna go back up to my sum and difference identities and do tangent, and I want to minus them. So I gotta see what the signs look like if I minus. So let's zoom up there. So tangent, it says signs match on top and signs are opposite on bottom. So we're minusing. So we need minus on top and plus on bottom. So it's gonna be tangent of alpha minus tangent of beta all over 1 plus tangent of alpha, tangent of beta. All right, minus on top, plus on bottom. Okay, let's go write it down. So tangent of alpha minus tangent of beta over 1 plus tan of alpha, tan of beta. All right, everyone okay with the formula so far? Pretty basic. Now we got to figure out what tangent of alpha and tangent of beta are and then solve from there. So let's go to our little triangles and let's figure out what that would be. So if I'm looking at alpha, tangent is opposite over adjacent. So tangent of alpha is 3 over negative 4 or negative 3/4. So actually, let me go fill that in first. Okay. So every time I saw tangent of alpha, I replaced it with negative 3 over 4. So now I got to figure out what tangent of beta is because I'm going to replace all the tangent of betas with that. Tangent of beta, tangent is opposite over over adjacent. So negative 12 over 5. Okay. Negative 12 over 5. Oh, I did this wrong last class. Not the first time, not the last time. Sorry, F period, I messed up again for you guys. Okay, before I start solving, let's kind of look at what we've got. I see that I've got a minus and a minus right here. So I'm gonna combine that just to be one big plus. You can say plus a positive, or you can do a big plus sign here. And then I want to get like denominators so that I can solve later on. So I'm going to multiply, let's see, I've got 4 and 5. So I'm just going to multiply by the opposite denominator, and I'm going to get 20 as a common denominator. So multiply the first fraction by 5 on top and bottom, multiply the second fraction by 4 on top and bottom. So that gives me negative 15 over 20, and then plus 48 over 20. That was not any nicer. Okay. Now on the bottom, I can multiply negative 3 over 4 and negative 15 over 5. So I've got 1 plus. I do want to cross multiply or cancel out here if I'm able to. So 15 or 12 and 4 become 1 and 3. And this is what I did last class. I forgot that negative times a negative becomes a positive. So that should be positive 9 over 5. 3 times 3 is 9, 5 times 1. Yep, there we go. I made that negative 9. So if you're watching back, F period, my fault. Let's add the top. So negative 15 plus 48 becomes 33 over 20. And then actually the bottom, let's make that 1 just be 5 over 5. I don't want to waste any more time doing steps where I can get like denominator. So 5 plus 9 is 14 over 5. And then we just multiply by the reciprocal. 33 over 20 times 5 over 14. 20 and 5 becomes 1 and 4. 33 and 14 have nothing in common. So it's going to be 33 over 56. Yeah, I'm okay with that. You guys okay with that? Okay. It's really easy to lose a negative like I did with the other class, so just be super careful with that. I also did not mean to zoom away. Here's this problem again. This is all just fractions. So if you're struggling or you're like not really sure how I got from one step to another, just kind of break it back down to basic fraction stuff. All right, the last two, one's double angle, one's half angle, that's 5-4. So sum and difference was 5-3, and I might even write that in my notes in case I forgot. Those two were like basically 5-3 formulas. And then C and D with the double 2x and then the half or 2 alpha and then beta divided by 2, that's the half angle. Those were the 5-4 ones. So I'm going to go look in 5-4 to see what cosine of 2 alpha was. Remember that for alpha, they gave us sine of alpha. That's going to be important in a second. So cosine of 2 alpha or 2x or 2 theta or whatever you want to call it, there were 3 different formulas for you to choose from. I would personally choose the middle one. And the reason why, and I just mentioned this kind of in passing, is that they gave us in the problem sine of alpha. They told us sine of alpha was 3 over 5. When I'm solving these problems out, I kind of want to use as much as what's written and less of like the work that I did, because if I messed up, I want to use like the most correct work. So I could do cosine squared minus sine squared. I could do 2 cos squared minus 1, but I want to do 1 minus 2 sine squared of alpha. 1 minus 2 sine squared of alpha. And again, the reason is even if I didn't do my nice pretty drawing, I was given sine of alpha. That was given to me. I did not make that up. I didn't have to solve that. That is correct because it was the problem. So I'm going to use that in my problem. So 3 over 5 is sine of alpha. So you can think of this as 1 minus 2 times 3 over 5 squared. And then we solve from there. When you have sine squared of a number, it means that you're squaring the sine. You're not squaring the angle. You're not squaring anything else. You're squaring like the function, and that's sine. So sine of alpha, sine of anything, is like a fraction. It's the ratio of opposite over hypotenuse. So I'm going to solve this. 1 minus 2 times, don't forget to square before we multiply, exponents before multiply and PEMDAS. So I've got 9 over 25. Multiply by 2. A big mistake I still see us doing is that we're giving 2 on top and on bottom. 2 times 9 over 25 is not 18 over 50. It's just 18 over 25. You can think of it as 2 over 1 if that helps you multiply your fractions better. Now I've got 1 minus a fraction, so let's make them have like denominators. 1 is just the same number over the same number. So in this case, I want my like denominator to be 25. So it's 25 over 25, and 25 minus 18 is 7. So 7 over 25. I know I kind of speed raced through that one, but I didn't feel like there was a lot to share. All right. Oh, sorry.
How do we know like when we use the 5-3 and 5-4? Like just by looking at the problem? Like how do you know?
Yeah, great question, Becca. Basically, 5-3 and 5-4 are just totally different formulas, right? So like I just know where to look because I've, set these notes up and I know what's happening. But if you were to go through all of your formulas and you're looking for cosine of 2 theta, I'm just telling you that if we went back to 5-3, all we did in 5-3 was the sum and difference formulas, and those are not cosine 2 of an angle. So I could look in here and I'd be like, okay, none of those match this. Let's keep rolling to see what else we need. And then I would come down here and I'd be like, okay, well, it's not the half angles. Oh, it works with this one. Does that make sense?
Yeah, thank you.
You're welcome. And what you could even do is put them all in like one sheet. If you wanted to scroll all the way down to your notes, or I even think like on our paper notes, like we only use half the sheet. So you could just write all the formulas that we've ever looked at together on one place, and that can be your reference. And you don't need to know if it was 5-3 or 5-4. I'm just giving you a little hint to know where to look. All right, and then the last one we're gonna do is cosine of beta divided by 2. So that's a half angle. We're not adding two angles together. We're not timesing by 2. We're dividing by 2. So again, you can go look at your formulas, but I know that that's gonna be here, cosine x divided by 2. Okay, and I have it highlighted just from the last class. So I know that I'm gonna use this formula, plus or minus square root of 1 plus cosine x divided by 2. Plus or minus square root 1 plus cos x divided by 2. Okay. Again, you might be able to copy and paste better, but I have to like remember it. So plus or minus 1 plus cosine beta divided by 2. Okay. And then cosine beta was given to us actually too. So I'm going to go back up to the very beginning. Cosine beta was 5/13. So I'm just going to plug that in and I'm just going to simplify. This whole problem is all algebra. It's not necessarily easy algebra, but it's all algebra. And instead of cosine beta, it's 5/13. Okay, that's as good as that 3 is gonna look. All right, now we just have to start simplifying. So I want on top, I wanna add 1 plus 5/13, so I need like denominators. So I'm gonna make that 13/13 plus 5/13 all over 2. Don't lose your 2 in the bottom. 13 plus 5 is 18/13 all over 2. I'm carrying my plus or minus with me until the very last step, and then I'm going to decide what it's going to be. But just keep carrying your plus or minus. I've got a fraction divided by 2, so I'm just going to multiply it by 1/2. So I've got 18/13 times 1/2. The reciprocal of 2 is 1/2, so when I multiply by the reciprocal, it's 1/2. 18 and 2 both have a common factor of 2. So that gives me plus or minus radical of 9/13. Now, sometimes we got here and I just was like, all right, this is it. And if we couldn't simplify anymore, I'd be okay with us leaving it here. However, I do see a pretty easy way to simplify it since 9 is a perfect square. And then we're going to have a radical in the denominator and we'll just rationalize it. So this is an okay way. If we can keep going, though, I do want to kind of push to keep going as long as possible. So root 9 is the same thing as 3. So I now have plus or minus 3 over radical 13. Well, that is a terrible mess. And then to rationalize, just multiply by root 13 on top and bottom. So I've got 3 root 13 over 13. And now I'm going to decide whether it's plus or minus. So I'm going to erase that box in a minute, but know that I didn't forget the plus or minus. I just haven't decided yet. I'll scroll back out in case you need to see my simplifying. Now, to determine plus or minus, I need to think about what quadrant I'm going to be in. Beta is in quadrant 4, so we're essentially doing half of that. Half of an angle in quadrant 4 is going to be somewhere in quadrant 2 2. It's only going to be in quadrant 2. Last class, I was like, oh, it's going to be 2 or 3. I didn't think hard enough about it. Let me just give you a little bit of my thought process. If it's in quadrant 4 somewhere, it's between 3 pi over 2 and 2 pi. And if I do both of those divided by 2, if I do half of 2 pi, it's between pi. And if I do half of this, that's going to be 3 pi over 4. So that's somewhere in here in quadrant 2. Even if it was in quadrant 3, it wouldn't matter because cosine is going to be negative in both quadrants 2 and 3. Again, I know that we didn't lose all of our brain cells, but I know we lost some over spring break. All students take calculus. Cosine is only positive in 1 and 4. So if it's in 2, or even if it's in 3, it's going to be negative. So I'm going to make it be a negative 3 root 13 over 13. All right. Questions, thoughts, comments? These worked out really nicely. A lot of what we just did was algebra. Algebra, like multiplying by the reciprocal, rationalizing, getting like denominators. The first step was our pre-cal step using our identities that we've learned last week or 2 weeks ago, excuse me. But all of this was mostly algebra. Okay, so we have officially finished 5-4, and I think I said this at the top of class, but that homework is going to be due on Thursday. I know I don't see you, but that homework's due on Thursday. Okay, we're going to get into 5-5 now. I want to get started there. There are 4 problems that I want us to do, and we're in class until, okay, about 20 minutes. I think that's about how long I did with my other class. Everybody good so far? Any thoughts, questions, concerns, comments, jokes, stories? Okay. All right, lesson 5-5. I know I did not teach this to you guys in academic geometry. I have no reason to believe you learned it in Algebra 2. If you took honors geometry by any chance, you probably have seen this before. It's not hard, but it's going to look a little bit different than we've seen before. So what I'm going to teach you now is something called law of sines. So 5-5 is law of sines, 5-6 is law of cosines, and these are just formulas we're going to use. So everything we've done so far has kind of been like a formula. Law of sines is are essentially proportions that we're going to set up. So it's going to go sine of A, sine of big A over little a equals sine of big B over little b equals sine of big C over little c. And actually, maybe you've seen this setting for SAT, ACT. I can't remember if this is on standardized tests or not, but it might look more complicated than it is. I'm going to argue this isn't that hard. It looks like 3 equations. You're like, Ms. White, we've never seen something like this. You never use all 3 of them. You just use 2 of them at a time. So we might do A and B together and set that up as an equation. We might do B and C together, set that up as an equation. And then we might do like A and C. We might just kind of cut and paste. It doesn't really matter. In order to find one piece of information, you need 3 others. So you either need 2 angles and a side, you need 2 sides and an angle. Those are kind of the possibilities that we have here. All of these problems say solve the whole triangle. So solve triangle CHS. That means find everything. So that means we need to find out what big C is, what big H is, what big S is. Those are the angles. And then we need to find little c, little h, and little s. Often on quizzes and tests, and then even like for myself, I like to set this little box up so that I know that I'm not done until this box is full. I did a problem like this on your test for 4145, I think, but it was with right triangles. So all it was trig and Pythagorean theorem. We can't use those because these are not right triangles. So that's why we now introduce law of sine. So let's fill in what we already have. I already know that big C is 60. I know that big S is 45. And I can actually find big H really easily by knowing that all of the angles in a triangle are 180. So I'm going to do 180 minus 60 minus 45. And I believe that's 75. Yep, 75. And then I was also given little s The little letters are just across from the big ones. So big S is the angle that's 45. The side that's across from that is 3.7. So I have little s is 3.7. Now we just have to set up our proportions using law of sine, and then we find little h and little c. Again, I would argue to use the pieces that are given to you. So I'm going to use 45 and 3.7 to find both c and h. You can use the pieces as you find them along the way, but I'm afraid I'm going to mess up and then use a mistake the whole way. So let's set this up. The first one is going to be sine of 45 over 3.7 equals, and then I can pick either of the two other ones. We'll do little c first. We'll do sine of 60 over little c. So this is my law of sines. I did sine of an angle over its opposite side equals sine of an angle over its opposite side. I just don't know what little c is, so I'm going to find that. Anybody questions on my setup? All right, cross multiply. I get c sine of 45 equals 3.7 sine of 60. And then I'm going to divide by sine of 45. So I'm going to get c equals 3.7 sine of 60 divided by sine of 45. Now, at the very beginning, you could have plugged this in the calculator and gotten your decimals and gone from there. I prefer to wait until the end, but I'm going to pull up my little calculator now and then solve this with you guys. So 3.7 sine 60 divided by sine 45. Now, I know I'm in degree because I did this problem literally an hour ago. But if you are just now looking at your calculator, make sure your mode is in degrees and not radians, because all of these are going to be in degrees. All right, so I am sine 3.7 sine 60 divided by sine 45 is 4.5. I'm just matching the decimal that was given to me. So since they gave me 3.7, I'm just going to go one place after the decimal too. So I'm going to go fill in this. I'm going to put little c is 4.5. And then I'm going to do one more sine, law of sines in order to solve. I'm going to keep sine of 45 over 3.7. And now I'm going to do sine of 75 over little h. I'm going to write that down and I'll scroll back out so you can see what I've done. Sine of 45 over 3.7, sine of 75 over little h. Again, this is what I've done so far. Cross multiply. H sine of 45 equals 3.7 sine 75. And then divide by sine 45. So little h equals 3.7 sine 75 over sine 45. Plug that in, 3.7 sine 75. Ooh. And then divide by sine of 45. 5.1. All right. We got 3 more problems just like that. Any questions so far? If you're feeling good, I encourage you to just head down, keep working, check in with me every so often. I'll have my little answers up, but kind of see what you can do. If you are still not really sure what's going on, I'm just going to walk right on through with you, so no worries. The next 2 don't have pictures drawn with them, so let's draw a picture really quick. It does not have to be exact. Don't freak yourself out. Just draw a little triangle. C, H, S. C is 40. H is 30. And then little h is 10.8. That 10.8 is across from the 30. Let me draw my little box so I know what I'm finding. CHS, CHS. Big C is 40, big H is 30, and then little h is 10.8. I always think it's easiest to find that missing angle first and then do my two law of sines, but you can do whatever floats your boat. So I'm going to do 180 minus 40 minus 30. Oh, wow. Let me try a little harder on my handwriting. $180 minus 40 minus 30, that's 110. I don't need a calculator for that. And then now I'm just going to do law of sines to find my missing sides. So I'm going to do sine of 30 over 10.8 equals sine of 40 over x or c or whatever you want to call it. So I'll solve that out before I set up the other part. C sine of 30 equals 10.8 sine of 40. Divide by sine 30, so 10.8 sine 40 over sine 30. Oh, that's not what I want. I got 13.9 for that one. Oh, shoot. Anybody, any questions so far? Same idea for the next one. Little s. I'll still do sine of 30 over 10.8, but then I'll do sine of 110 over little s. I don't know if I said that right, so I'm going to zoom out so you can look at it real quick before I solve. I normally don't like using variable of s because it looks too much like a 5 with my terrible handwriting. And when I just like right here, I had s sine 30, that's kind of messy, but it is what it is. You can always use another variable if you want. I'm now going to plug in the calculator, 10.8 sine of 110 divided by sine of 30, and I get 20.3. All right. We got one more like this and then one more after that. Draw my picture. I know angle C in this next one is 53. I know angle H is 48, and I know little s is 19.1. Here I do want to find that third angle before I do anything else. So 180 minus 43 minus 48, or 53. I mean, I said those wrong. $79. And again, I don't know if I just thought this or if I said it out loud. If you're tempted to use Pythagorean theorem, remember that doesn't work because it's not a right triangle. So all of these are non-right triangles, which is why we're doing law of sine so many times. So I'm going to do sine of 79 over 19.1, and then either angle is fine. I'll start with sine of 48 over little h. All right. Little h, sine of 79 equals 19.1 sine of 48 divided by sine of 79, 19.1 sine of 48 over sine of 79. Make sure you don't lose your sign in the denominator. I did once last period, and it's going to make a big difference. So just make sure you don't lose that sign ever. 19.1 sine of 48 divided by sine 79. I get 14.5. And again, it's important that you know which thing that you're finding, whatever you label them as, just know what side you're finding. So I just found little h. Now I need to do little c. So sine of 79 over 19.1, and then sine of 53 over little c. Where we're at so far. All right, let's find little c. Divide by sine 79, so 19.1 times sine of 53 divided by sine 79. Throw that in the calculator. And I get 15.5. Yep, that's what I got last period. All right, so we've just done a lot of basics law of sines. I'm going to do one more problem. I want to do a word problem before we're done for today. We're going to skip number 2. Well, before I move on, any questions? Any thoughts? This isn't hard. It's a little bit of work, so it's a little tedious. Like there's a lot of steps here, but I don't think it's difficult. You just got to use your calculator, so don't forget to have a calculator when we do these. We're going to skip number 2 because that's a special case. We'll look at that later. We're going to skip number 3 and number 4, but we're going to do number 5 really quick. Sometimes we look at a word problem and we immediately are like, man, I don't know how to do this. You do know how to do this, which is why I'm squeezing it in right here at the end of the lesson. It says 2 lighthouses, A and B, are known to be exactly 20 miles apart on a north-south line. So A and B are right here. They are 20 miles apart. And then we have a ship over here. And the angle from from lighthouse A to the ship to angle B is 33 degrees. And then the angle from lighthouse A, lighthouse B to the ship is 52. I even labeled it so you don't even have to digest what that means. And then it says find the distance from the ship to each lighthouse. So the ship's out here in the ocean. From the ship to lighthouse B is little a because it's across from angle A. And then the ship from lighthouse, or from the ship to lighthouse A, is little b. You don't even have to read this information. That doesn't even matter. We can just look at the picture and know that we need to find the two sides that are missing. Essentially, we're solving this triangle. Before I do anything, let's find little a. So, or big A, I'm going to do 180 minus 52 minus 33. That's 95. And then now I just have some law of sines. The one thing that's given to me, both pieces, I have angle 33, side 20. So I'm going to use that for both of them. I'm going to have sine of 33 over 20. And then I'm going to alternate between finding the distance from the ship to lighthouse A or the ship to lighthouse B. So from the ship to lighthouse A, that's going to be little b, or you can call it x. I don't care what you call it, but just know what you're finding. So that's going to be 50 sine of 52 over b. So let me move that. Sine of 33 over 20 equals sine of 52 over b. Again, this over that. Now we're going to do the same idea, but the other side. So I'm going to keep sine of 33 over 20, and now I'm going to do sine of 95 over a. Sine of 33 over 20 equals sine of 95 over a. And again, I'm going to move that. And then I'm going to solve both of those. Any questions on the setup? I know we're right at the end, but I'm going to solve these very quickly. Okay, so stick with me for a minute. Cross multiply b sine of 33 equals 20 sine 52. Divide by sine of 33. B equals 20 of sine 52 divided by sine 33. Which is 28.9. So again, I'll erase some of this nonsense. That's this side right here, 28.9. And then the last one to find little a sine of 33 equals 20 sine of 95. Divide by sine of 33, 20 over sine 95 over sine of 33. And that equals 36.7. 36.6. I don't know what I was thinking. All right. So I know that we did that quickly, but it was a simple problem like the three that we just did before. So I just thought we'd practice that so that we're ready. So 2 reminders, we're going to do a small quiz tomorrow. You can use your calculator, you can use your notes, you can use your formula. 2 questions from 5.3, 2 from 5.4, 1 from 5.5. Your 5.4 homework is due on Thursday because we finished that today. I have not assigned 5.5. If you're missing any homework from before break, today is a great day to turn it in. Okay. All right. Any final questions on our notes? All right. I'm going to stop share. I'm going to stop recording.